a look at this group juggler problem here. Okay, so a juggler performs in a room whose ceiling is 3 meters above the level of his hand. He throws a ball upwards so that it just reaches the ceiling. What is the initial velocity of that ball? Okay, so I'm not going to list the variables on this one since this is kind of a practice type problem. But I will say, all right, I want to find the initial velocity of the ball. Well, when it reaches the ceiling, the velocity is going to be 0. So v squared equals v naught squared plus 2ay minus y naught. I'm going to choose the height of the ground to be 0. The max height will be my y. The velocity at the max height is 0. I'm trying to find v naught. And so v naught is going to be plus or minus. It's going to be the plus square root of negative 2 times negative 9.8 times the height, which was 3. And so the initial velocity required so that it will just reach the ceiling, it won't actually run into it, it'll come to a stop there, is going to be 7.67 meters per second. That one should have been okay. Part B then wants me to know, what is the time required for the ball to reach the ceiling? Okay, so now I just need to find the time for that to occur. Now that I know the initial velocity, that makes it a little easier. I can just say v is equal to v naught plus at. Cross that out, put that all in there, so I have negative 7.67 divided by negative 9.8 will give me the time it takes to reach the ceiling. You should have got something like 0.782 seconds. Okay. Now, this is where the trick came, the juggling act, if you will. At the instant when the first ball is at the ceiling, the juggler throws a second ball upward with 2/3 the initial velocity of the first. How long after the second ball is thrown do the two balls pass each other? And at what distance above the juggler's hand do they pass? Okay, so we're going to kind of lump C and D kind of in the same group here because it is the same kind of setup. Now, because there is one ball falling and one ball going up, this is going to be a simultaneous problem. So for the one falling down, okay, so for the one falling down, I'm going to use the third equation. So the height it's at is equal to the 3 meters it starts at, plus when it reached that maximum height, it was stopped, plus 1/2 times negative 9.8 times t squared. The one going up, slightly different. So the height is going to be, well, it's starting at 0, plus 2/3 that initial velocity over there, t minus 4.9 t squared. That's that 1/2 negative 9.8 there. All right, so I want to first find the time. So since they're both equal to y, I'll just set them equal to each other. Some of the things we had to be careful of is we needed to make sure that those times were the same and those y's were the same. That's why this one had to start at 3 meters up at that maximum height. I couldn't start it at this location. Otherwise, I'd have different times. Okay, so we'll set those two equal to each other. So I have 3 plus negative 4.9 t squared equals 2/3 v naught t minus 4.9 t squared. Fun thing happens. Shouldn't put a 0 there. Those two things are the same on both sides, so they cross out. And so I can multiply the 3, divide the 2, so I get 9/2 of, and then divide the v naught over, so we better put that on the bottom, equals t. The v naught here is this value, so I'm going to plug that in. And I should get a time of 0.587 seconds. Now that I know the time, I should be able to plug it into either one of these equations to find the position. So y is going to equal 1.3, we'll leave it at 1.3 meters high, is where those two balls are going to pass. There you go.